The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, everybody. Thank you for joining me for today's 68 RFE Diagnostics Webinar. I'm ATRA Technical Advisor David Chalker, and I'll be chatting with you guys this morning. I want to thank you all for coming out and being a part of this presentation. So before we get started, I'd like to take a moment and thank today's sponsor, Seal Aftermarket Products. It's because of these sponsors that we're able to put these presentations on. So including Seal, we also have Transtar, WIT, System 1, Toledo Driveline, and also ATRA and Gears. So let's get started.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and ATRA transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda ATRA kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, and that was a word from our sponsor. So getting started, if you see material that is not shown in your handout, just double click on the camera icon at the top right of your screen and it'll leave a JPEG file on your desktop. Here at ATRA, we enjoy being able to put on these free webinars for you. But again, if we do not have sponsors, we don't have webinars. So I want to thank our sponsors again for providing this free training for you guys. And if we look over this list of webinar dates, we have 3 more coming up. The 6R80 in just a couple of weeks, the REO F08, 09A and B, and the 6T70, which will round out 2017. We hope to see you at each of them. Expo 2017. I know you guys are going. I know that you're already there. You're going to be there. So save that date, October 19 to the 22nd in Paris, Las Vegas, same place we had it last year. It's going to be better. Can't wait to see you guys there. Look forward to seeing you all. If you have not signed up, do it. Do it now. Well, don't do it now. Do it in about 50 minutes. Make sure that you're there because you do not want to miss this. It's going to be fantastic this year. I don't know how they keep improving year after year, but they certainly do. It's just amazing. So during this presentation, if you have any questions or comments, send an email to webinars@atra.com. Love to hear from you. If you have any questions during the webinar, feel free to just text them in at any moment. There's a tab labeled questions, and you can just send them in there. So to start out, we'll start with some basics on these. 68 RFE came out in 07 in the 25 and 3500 Ram pickups using the 6.7 Cummins turbo diesel motor. The basic design and operation is similar to the 45 RFE and the 540 RFE, with a few exceptions. They have a different bolt pattern, different bell housing to accommodate that 6.7 diesel motor. They've got some modified internal components, gear ratios, and things to handle the increased torque that 6.7 diesel motor puts out. So with those optimized gear ratios, it provides a wide ratio capability and gives improved efficiency features as well as reducing any noise, vibration, and harshness that have been present before. Another thing is on these models, there is no second gear prime during downshifting like you have with the 45 and 545 RFEs. So here we show the gear ratios. You've got the 68 RFE in the center there. And if you look at that gear ratio, you'll see that it's different from the 45 RFE, the 545, and the 65 RFE. It's the same as the 66. Since there's a difference between those, different gear ratios indicate different planetary gears. So you got to be careful when you're, if you were to interchange things or try to interchange. Here we have nominal values for your CVIs. Oftentimes CVIs can be a valuable tool when you're diagnosing. Here we provided the values for you as well as the update details. That way, if you have a particular gear or a particular clutch volume index that's not showing the right numbers, you can provide or perform the appropriate shift in order to update those values so that it's either going to update and the values will fall in line by performing those downshifts or upshifts, or it's not, and you're going to be looking at issues internally. So here we have an apply chart, just your basic apply chart. You will notice that on your low reverse clutch is on when output shaft speed is below 150 RPMs. And that's the only time that it's going to be on in drive is when you're below 150 RPMs. If you look at the TCC, that can be on in third gear, but the computer turns TCC on after the shift to fourth gear, unless the tow haul mode is enabled. If tow haul is on, then TCC will lock up after third. So that's one thing to keep in mind when you're driving if you're looking for TCC operation. Here we have your pressure switch chart, basic open and closed chart. If you look at the drive first gear, your low reverse pressure switch, that switch is closed, but when your output shaft is below 150 RPMs. Above that, clutch is turned off. So when you have the scan tool on it and you're driving it, you're going to see that low reverse pressure switch state change as you're taking off. That is normal. It should do that. There's a few limp-in mode differences. The earlier models with manual 1 and 2, they have a provision for providing second gear limp in. Usually it's third. If there's no power to the trans, usually have fourth gear in reverse. That's all you're going to get. Same with the later models. With no power to the unit, you're going to have fourth gear limp in. If actual limp in on those also is fourth gear. So no power or limp in, that's going to be fourth gear. Seen a lot of times where a vehicle will shift from 1 to 4, 2 to 4, and then just stay in fourth gear. And that's usually because the thing has gone to limp mode and it's got codes, or you've lost power. Here we have an 08 and earlier solenoid application chart. If we look at this, you'll see that your overdrive solenoid here, it's not on in fourth gear or fifth gear, but the overdrive clutch is on in fourth, fifth, and sixth. So the overdrive solenoid is only turned on for sixth gear. And it goes in conjunction with the multi-select solenoid. So that solenoid is off, the multi-select solenoid is off in fourth and fifth gear, and that solenoid is turned on with the overdrive solenoid for sixth gear, but only on the 08 and earlier models. On 09 models, 09 and up, you'll notice that the overdrive solenoid is not there. They got rid of it. So you don't see it in the chart, and if you look at your multi-select solenoid, that solenoid is off in fourth, fifth, and sixth gear. And I'll show you how that works here in just a second when we're going to look at some hydraulics. So the reason for those two changes, or for that change in the solenoid apply, in 2009, Chrysler removed the overdrive solenoid from the solenoid pack. And they changed the color of the connector, went from white to gray. So the vehicles before 09 used the white connector solenoid pack that has the overdrive solenoid on it. And again, that solenoid was used to turn on the overdrive clutch, but only in sixth gear. Okay, remember, fourth and fifth is controlled by the multi-select solenoid. When they removed the solenoid from that body, you needed other changes to accommodate the removal of that solenoid. So they got rid of the number 6 and 7 check ball. Those were removed from the valve body, and they made changes to the spacer plate to accommodate that check ball and solenoid change. And we'll show that here shortly. So here you've got your late and your early solenoid pack. On the left is your early. It's the white connector. And here on the right, you have your 09 and up with a gray connector. You cannot use a solenoid pack with a gray connector on a pre-09 vehicle. But you can use a white connector solenoid pack on an 09 and up vehicle. It will work fine. So keep that in mind. Now, here we have the hydraulics to get into what we were talking about with that solenoid change or the solenoid removal and stuff like that. Here you show a hydraulic diagram, 08 and earlier, and this is in fourth gear. So remember, in fourth gear, we said that overdrive solenoid is not on. So this shows that solenoid is off, it's not flowing. And your overdrive clutch is fed through the manual valve by the multi-select solenoid. That multi-select solenoid is a normally applied solenoid. So when the solenoid is off, it's flowing. And so this shows that solenoid off. If you look here, it shows that that solenoid is off and oil is flowing, seats this number 6 check ball, and applies the overdrive clutch. Now, if we look at the 09 and up, again, this is fourth gear. That solenoid is gone. Your number 6 check ball is gone. Your number 7 check ball is gone. And also your 2 and 1. So if you look here, this circuit here is for your 2 and 1. You have a drive and a manual 2-1 position. And on the 09 and later, they got rid of that 2 in 1 position. So you have a D2L or just a D. And so your multi-select solenoid operates your overdrive clutch, and no check ball, no number 7, no number 6, no number 7, and no solenoid. And again, that's 4th gear. So if we look at 6th gear, here's where we see the early model, the early version. That multi-select solenoid is now on, so it's not flowing. So this passage is empty, but your overdrive solenoid is on, seats the check ball this way, and applies the overdrive clutch. But again, all this plumbing here with the 7 check ball, number 6, and the solenoid, and the D2-1 circuit is gone, as we see here. None of that's here. So now it's just the multi-select solenoid that operates the overdrive clutch. Excuse me. Now, this is good information to know working on these. If you have an issue with one of these vehicles going to 4th gear and it neutrals or slips or whatever you've got a problem with a 3/4 shift, we know the overdrive clutch is coming on. But don't go replacing the overdrive solenoid. Don't go pulling the solenoid out and replacing it with another one, because that's not the problem. So it's good to know that to avoid doing unnecessary work. So if you've got a problem with the overdrive clutch in 4th or 5th gear, it's definitely not caused by the overdrive solenoid. Same thing on your 545s and your 45s. The overdrive clutch won't be causing the problem, or the overdrive solenoid will not be causing the problem unless you're in your highest gear before 2009. Okay, so before 2009, when they got rid of the overdrive solenoid would control the top gear. Okay, which means 5th gear for 45 and 545 models, and 6th gear for 66 and 68 RFE models. So keep that in mind when you're diagnosing. That'll help, it'll help save some time and save some work that just doesn't need to be done by pulling a solenoid pack and valve body down and, replacing that solenoid. You don't want to look at the overdrive solenoid if it's not at fault. You want to look at your multi-select solenoid or something else in the circuit with the overdrive clutch itself. So that's an important thing. So again, here, there's the check ball locations, number 6, number 7. Those check balls are gone. Valve body looks exactly the same, just no check ball. And you do have your different plates. So your early plate has the 2 feed holes for your check balls, your number 6 and your number 7. Here, number 7 is blocked off. There's no hole. Number 6 is blocked off. And of course, they've added an exhaust as well in the circuit. So now that moves us on to some code issues that we have, some code issues that we see. I see a lot of problems. A lot of vehicles come in with a P0882, power input low. That code basically indicates that the TCM, or the trans control system, detected less than 3 volts when the circuit is commanded on, or this output mode. So the computer controls this relay in the TIPM, and when that is turned on, if the computer detects less than 3 volts on this circuit anywhere, 2 consecutive times, it's going to set this P0882 code. Ordinarily, this would be an easy issue to solve if the problem is there all the time, because you'll be able to identify which circuit is low, which circuit's being pulled down. The problem occurs is because this is usually an intermittent code, and it usually occurs, who knows, every 10 hours or 15 or, every other day or every other week or something like that. So it can be a very difficult code to diagnose, very frustrating. So what I do to try and avoid that frustration is the first thing we want to do is we want to look at the wiring to find out what's involved in the wiring. So if we look at this 0709 circuit, we see that coming out of this TIPM, this circuit here, this is your T16 circuit. You've got 3 splices here. So you've got 3 separate wires to worry about at this C4 connector. And you've got this C130 connector, this inline junction connector to worry about. Same thing on this T15 circuit. You've got this C130 inline connector to worry about. Typically what I will have a guy do is go locate this C130 connector, go to this side of that connector and cut the wire and just run a jumper. Just piggyback a wire from over here down to 19, 28, 38 of this C4 connector. What that does is that bypasses this connector and it bypasses those splices and takes them out of the equation. Same thing with the C130 connector here, with this here. We just locate the connector, the inline junction connector, cut the wire and run a jumper down. This way, by doing that, you can drive the vehicle and see if the code comes back. If the code does not come back, you know that there's a problem with this connector, with this inline connector, or the splice. If the code does come back, well, that creates a bit of a problem. So then what you're going to need to do is you're going to have to monitor the voltages, or you have to change parts. And typically a guy will change the TIPM, and then they change the PCM, or maybe they change the PCM first and then the TIPM. It doesn't really matter. It's usually you spend money you don't need to. So at this point, when the problem's intermittent that way, and we've already bypassed these wires and taken care of that circuit, I recommend using an oscilloscope or a graphing meter. And for this circuit here, you're going to need, at least 4 channels. And so you're going to need to set that meter up or that scope up in a record mode so that you can drive the thing and watch the voltages when the problem occurs. Unfortunately, that's what we have to do, or you're replacing parts. I mean, it's just the name of the game. So that's the best way to do it, is by bypassing the circuits first, ruling out these connectors, ruling out these splices, and many times you're going to find the issue, or the issue is going to be created, it's going to be resolved. Otherwise, you're going to be looking at a TIPM issue or PCM issue. Now, don't forget the grounds. You got to check the grounds as well. You have to make sure that on your grounds they're reading less than 0.1 volts. Got to be less. I would splice and run a new ground even if it read 0.09. That's a little high. I have seen grounds with 0.1 and 0.15 volts cause problems. So you definitely don't want to do that. So if you've got a question on that ground and you've run a voltage drop and you see your voltage is up, 0.09, 0.1, splice into that wire, take it to the battery negative terminal, make sure that voltage is low, 0.001, whatever. Make sure it's there. If it's not, you're likely going to have problems. So now, here's your 0709. Here we've got your C4 connector down here. There's your C4 terminal identifications. You've got your S125 splice in here. So if you really want to, you can peel all this harness back and open up those wires and go through and inspect each of those splices, and you can run an amp draw test, an amp draw circuit test on each one of those splices. Or you can bypass the wires like I mentioned. That's what I would do. And again, here's your C130 connector. So you want to go on the other side of the connector and make that splice and run those wires. So now here's 2010 to 2012. Now, on these circuits, you've got 3 different versions. You've got 0709, you've got 2010 to 2012, and you got 2013 and up. And basically, you've got different PCMs, different connectors, different pin assignments, a lot of different changes. So the circuit is checked exactly the same way. You just have to be aware of what you're dealing with. So the 07, 08, 09, 10, 11, and 12, they've still got this C130 connector. So to check this intermittent issue, you're going to bypass that C130 connector, bypass that S184 splice. And of course, don't forget the grounds. So this should say 2010 to 2012 because the earlier models, they use a different PCM. This here only uses 2 connectors. 2010 to 2012, 2013 and up have 2 connectors at the computer. 0709 use 2 different controllers. They use an engine control module and a powertrain control module. This is just a PCM. And so here you have terminals 1 and 27. So you've looked back here, you got 27 and terminal 1. And those are the locations in the computer connector, and there's the location of your C2 connector. Here's your C130 connector, and again, just cut the wire, run a jumper. And here is your C130 splice for 2010 to 2012. Again, here's your connector on the 2010 to 2012. Earlier models, it was over here, so they've moved it. So the reason I've added this information on these different years is so that you're not looking for a C130 connector over here that doesn't frickin' exist. So 2013 up, same idea, same exact idea. But if you see here in this circuit, there's no C130 connector. So we don't have a connector to worry about there. We don't have an inline connector. We do still have this splice, so we can still run a jump wire for both, but you don't have that connector to contend with. So keep that in mind. Excuse me. 2013 up, here's your PCM C2 connector. You'll notice the connector has a different configuration, different number of pins. It's in the same location, but it is different. Terminals 24 and 74 instead of 27 and 1. So again, that information is there, so we're not looking for stuff that's not there. So next thing is line pressure related codes. A lot of issues with those. I see a lot of calls, a lot of cars with a P0868, line pressure low. That's a common code. P0869, P0933, not as common, not near as common. P0934, P0935, also fairly common. P0868 sets when, or rather if, actual line pressure is more than 15 psi below what the desired line pressure is. So if that code sets, that's the reason why, because line pressure is actually low, or the computer thinks it's low. And we'll get to these, once I go through these codes real quick, we're going to look at some screenshots of a scan tool so you can see or have a better idea of actually what you should be looking at and how that sensor and solenoid work in relationship to these codes as well as with one another. All right, so your line pressure low, 15 psi below desired. Your line pressure high, again, I said that's not as common. If line pressure or your actual line pressure is greater than the highest desired line pressure ever used in that current gear, while the piece pressure control solenoid duty cycle is at or near its max value, it'll set this code. Now, pressure control duty cycle has a range. 5% to 60%. That's the 5% is the min, 60% is the max. Now, this doesn't work like, a lot of other units where you have your duty cycle comes up, your pressure comes up. This works the other way. When your line pressure or your duty cycle is at its max, let's say just for the sake of argument 60%, that is your minimum pressure. So 5% duty cycle, max pressure. Pressure is very high. 60% duty cycle, your lowest pressure possible. You likely will never see those readings. You likely will never see those values. It's going to be in the middle somewhere, but we'll get to that in a moment. So pressure sensor range or performance. Now, if you notice, the 868, 869, that's line pressure. These other codes, the 933, 934, 935, are sensor circuit codes or performance. Now this 933, if actual line pressure is more than 25 psi higher than desired, but is less than the highest line pressure ever used in that current gear, the DTC will set. All right, so again, 25 PS higher than desired, but less than the highest pressure ever used. So the lowest duty cycle ever used in that gear, the pressure has to be higher than that. Now, I'm going to show you a slide of a snapshot that will show you something similar to how that works and what the computer does in a situation like that. And then we've got P0934 and 935. 934, circuit low, 935, circuit high. Circuit low means low voltage. So if pressure sensor voltage is less than 0.35 volts, it's going to set a 934 code. Now, if that voltage goes over 4.75, line pressure sensor high circuit. That's pretty straightforward. Now we'll get back to those, and I'll show you the wiring in a moment and explain the circuit. But first, we're going to look at these pressures, because this is going to be important to helping you diagnose these things. So here we have minimum pressure. It's first gear, but it really doesn't matter. Minimum pressure is minimum pressure, okay? And what we look at is we look at our duty cycle. It's at almost 26%. We look at our line pressure. So at 26% duty cycle, or 25.97, we've got 61 PSI, almost 62. Our line pressure sensor and our line pressure solenoid are about equal in voltage. And line pressure sensor voltage, line pressure solenoid voltage should go up and down together with one another. Pretty much the same voltage, up and down. And so if you look, well, let's go to the next slide here. Here we've got max pressure, all right? So our duty cycle's less now. Before we were at 26, now we're at 15. Our pressure is 159 or 158 PSI. Our line pressure sensor and line pressure solenoid are exactly the same at 2.87. So when you're looking at your sensor and your solenoid voltage, they will go up or down with pressure. The higher the pressure sensor voltage, the higher the pressure reading. The lower the sensor voltage, the lower the pressure reading. And again, line pressure sensor, line pressure solenoid should go up and down. They should be the same. All right. So now we look at this one here. Line pressure is greater than the desired pressure. And you're going to see this, you'll see this frequently, and you'll see how the computer, takes care of the issue, how it controls pressure. So your line pressure, your measured line pressure, is 175, 176. Your desired is just 150. All right. Your duty cycle gets ramped up to 18%, almost 19%. Okay. So when you see that duty cycle go up, you'll notice that this voltage also goes up. So basically what's happening here, the sensor is reporting 2.3 volts. It's reporting this 175 PSI. The computer knows that that's way more than what it's commanding. So it ramps the duty cycle up. And if we look at that here, here's where we're looking at it right before that. Okay, pressure's high. The computer ramps duty cycle up. So from about 14 to almost 19% duty cycle goes up. And if we look here, here's your pressure, your PSI. When it comes up to that 18.8%, that line pressure drops right down. And if you look, you'll see there's your 150 mark. So from 175 right back down to 150, which is what the desired was. And so if you look at these graphs, you will see that they're a mirror image of each other, but just opposite. Same thing with your line pressure duty cycle, your line pressure solenoid voltage. Okay? It's like a mirror image, but they're the same. Same thing with your line pressure PSI and your sensor voltage. They're exactly the same. They're just like a mirror image. So you want to keep in mind when you're looking at this, the lower your sensor voltage, the lower the pressure is reporting. The higher the sensor voltage and also the solenoid voltage, the lower your pressure. Okay, so low pressure, low voltage, high pressure, high voltage. It's pretty simple that way. And it really helps to know that, because then you can look at the scan tool and pretty much know exactly where you are. So here we've got the your pressure related code. So now we'll look at your circuit high and your circuit low. So with voltage high, if you've got a high voltage, high circuit code, we need to look at the low side. You could have a ground issue. If you don't have a good ground, your voltage will remain high. So if you have a code for high circuit, first thing you want to do is splice into the wire, run a good ground, make sure that you've got a good ground. Now, what else can cause a high reading over 4.75 is an open sensor. So that voltage is just going through. You got 5 volts all the way through. So an open sensor, a bad ground, or a short to power on this sensor signal wire. If you have a short to power on that sensor signal wire, you probably won't see the voltage change. So that'll be a clue. Now, if you have a low code, a low circuit, the ground is not causing the problem. Because if the voltage is low, we know you've got a good ground. Okay, that means the circuit's being pulled low. So the indication is it's not going to be a sensor ground issue. Could be a bad sensor. That sensor could be shorted and pulls this voltage down so that you have less voltage here, which translates to less voltage here. So you could have a short in that sensor. Unplug the sensor, you should see your voltage go right to 5. If it does, you got a sensor problem most likely. Or you could have low reference voltage. That's simple to check. Check for 5 volts. If you got 5 volts, that's good. All right. The other possibility, other than the sensor being bad, is going to be that sensor signal wire being shorted to ground or open. If that wire is open, you'll have 5 volts here, but you'll have nothing here. So that's another thing you want to keep in mind. So that was this was 0709. Here's 10 to 12, same exact circuit, different connectors, different wiring, but the circuit is exactly the same. You check it exactly the same. 2013 and up, exactly the same checks, different circuit, same checks. So now that moves us on to the next piece, which is temp sensor related codes. See a lot of those. See a lot of P0818 codes. Don't see too many P0711 codes. See a lot of P0218 with P0712. Okay, that happens a lot. We see that a lot. We also see a number of P0713. That usually indicates that temperature is very, very low, like below zero, like 40 below. And then you've got the P0714 for an intermittent sensor. That's not a very common code. P0711 is not very common. P0714 is not very common. So the most common is the P0712 with the P0218 and or just P0712 by itself. Those are the most common. So again, exactly the same way as on the previous circuit. If you're looking at a low code, that code is caused by low voltage in the circuit. All right? Low voltage in the circuit means you don't have a sensor ground problem. So it could be a bad sensor. The sensor could be shorted, causing this voltage to go low, but it's not going to be a bad ground. Now, on the other hand, high voltage in the circuit, yes, this ground could be bad, causing that problem. So if you've got a P0712, don't bother checking the ground because that's not where it's at. If you've got a 713 code, yes, check that sensor ground, but also check for 5 volts at the sensor. If you've got 5 volts at the sensor, then that means that the sensor signal's getting there, but you've got an open in the sensor itself, or the ground is no good. Splice into the ground, run it to the battery negative terminal, or find the issue with it, problem will be solved. Now, the most common thing we see is that the code is intermittent. Truck comes in, the codes are there, but it works fine. You check it with an infrared thermometer, transmission temp looks great. You don't see any problem. You drive the car, you drive it for hours, you can't get the problem to come back. And the customer tells you it only happens once a week. You can't drive the car for a week and check it. So what I have guys do is I have them cut the wire for the temp sensor up at the PCM, not at the trans, but up as close to the PCM as feasible, and wire in a 1K ohm resistor. That's 1,000 ohms. Okay, they're easy to get. You can get them online. You can get them in electronic stores. But take and wire in this 1K ohm resistor just like it shows. Come out of the computer to the resistor, from the resistor to ground. Make sure that your connections are good. All right, solder the joint, whatever you do, make sure you have a good connection. If you wire the resistor in properly, now the code should never set again. Because coming out of the computer, you got your voltage. It's going through this 1K ohm drop to ground that is not going to change because it's a static resistor. So your temp sensor signal should never change. It should always remain the same. Two things will happen. The code will not come back, or the code will come back. If the code comes back, it's because either the PCM is bad, or this connector here is an issue, or you did not get this wired correctly. But, you know, typically guys, they wire them properly. So if the code comes back, it's usually a bad PCM. If the code does not come back, you've got a circuit problem, period. That means you're going to need to replace the solenoid pack, check the ground, check this wire, you know, for being shorted to ground or what have you. So if that code does not come back, you've got a circuit problem, so you got to fix it. Now, don't deliver a vehicle with the resistor wired into the sensor. Okay? Repair it. Fix it properly. If you wire this resistor in, you make the computer happy, and the trans is overheating, you don't want to get the trans so hot that it spits oil out and causes a fire or some kind of a problem. Fix the frickin' problem. Okay? So don't deliver a vehicle with that sensor or with that resistor wired in there. And so guys, that's pretty much what I've got for you today. I want to thank you all for being here. Again, today's presentation is sponsored by Seal Aftermarket Products. And I just want to thank you all for coming today. I hope to see you guys again soon. If you have any questions, please let me know. And thank you for attending. Have a great day. Bye-bye.